Hi there, this is Shrikant Dasari. So in this lesson we are going to learn about the dynamic memory allocation using calloc function. So which works the same way as malloc function with some differences. Okay. So let me launch the IDE. So already I have created a project under the name calloc, and we have a calloc.c file. Okay. So now let's take a couple of variables which are necessary and a pointer d array. Okay. So now let's make use of this calloc function. The syntax of calloc function goes like this. It is one and the same. The syntax is same as malloc function. The only difference is, so here we are, instead of multiplying the number of elements n times size of n, we have did it in that previous malloc syntax. Okay, so here the syntax a bit changes. Here we are changes like this: the size of int. Okay, this is the only difference. In the previous the malloc syntax, we are used to n times size of integer. Okay, so now we are taking n and both, and we are specifying the size of integer using this size of function here. Okay, so the malloc and calloc, the both sole purpose of both of them is to allocate a chunk of memory. So the difference between the main difference is calloc is more a bit advanced. It has some advantages of using calloc over malloc. Is that calloc sets all the elements or reserves whatever the bytes it reserves for its memory allocation to 0. Okay, so with that allocation, with that setting to 0, which means that it does not have any garbage values, which in turn avoids the problem of memory leaks. Okay, so all these things are design issues which needed to be kept in mind while writing a huge programs where the memory is very limited, and you need to make use of efficient usage of memories and avoid garbage values and etc and etc. Okay, so for that, for this instance, we can keep in mind that calloc has some advantage over malloc while using for memory allocation. Okay, so now let's see the process. So let's take a for loop here. Since we have allocated some bytes of memory, so we can run a loop as we did in the previous example to store some contents inside that dynamically allocated array. Okay, so in the previous example we are just taking input from the keyboard, and we are just then storing those elements in the array. Okay, so instead of that, we can directly, to make it simple, so let's allocate the array directly using some integers. Okay, so here I'm just storing some numbers in that dynamically allocated array. So let's take another for loop here to just to print those contents. So I less than n and I plus plus. Okay, printf %d and d array of I. So let's have a small printf statement here. So in order to differentiate a new line there. Okay, so now if we just save and run, before saving, so we need to enter that size here. Okay, so we have forgot that one. So the sole purpose of this dynamic memory allocation is that the user should be able, when the user does not know the size of the fixed size. Okay, so this is the drawback of having fixed size arrays. So with the dynamic memory allocation, so you can dynamically allocate some memory in the runtime. Okay, so the user might not know how many elements you have to take previously before while designing the programs. Okay, so enter the number of elements, or else enter the size, you can say simply. Okay, so you can enter the size, so that many elements you will be able to enter. Let's add a scanf statement. Okay, so %d ampersand n. Okay, so let us save and run the program here. Let's make it a bit bigger. So all usual processes here. Okay, so if you say 5, okay, so we never forget adding get statements here. Okay, so if you run the program here, if you take 10 elements, you get 10 elements displayed here. Okay, so in the same way, if you have per se, so if you have 47 elements, you need to be the size of an array, you get 47. Okay, so in that way the dynamic memory allocation works. Okay, so now to revise once again, so what we have done in this program using calloc. So we have the syntax is one and the same as malloc. So here the only difference is it allocates or sets all the bytes which were reserved, byte space which is reserved in the memory for our array, to initialize all of them to zeros. Okay, so there is one more thing, one important thing while allocating the memory using calloc or malloc is that you have to free or release whatever the bytes of memory you are allocating in your program. Okay, so if you keep on allocating and if you're not using this function free, okay, so free name of your pointer. Okay, so free d array, so frees or deallocates the memory, deallocates the memory. Okay, so deallocates the memory and it adds back to your system. Okay, so whatever the memory it has been taken from the system, so here it allocates. Let's have a comment here also. Allocates a chunk of memory or allocates some bytes of memory into this pointer, into this array, or you can say pointer here. So there is always a best practice to use a free function like calloc, malloc functions which were used to allocate some bytes of memory. The free function is used to deallocate. Okay, deallocation means taking back the allocated memory and using it for some other purpose. Okay, so in this way you can efficiently manage the system's memory, which is very crucial issue. Okay, so this is the basics about using a calloc function to allocate memory. So see you in the next lesson. Goodbye.